Cleaning datasets is probably one of the most time-consuming things that we can do once we import a dataset. Two important things that we want to look for are either missing data elements or inconsistent data elements. The first thing we want to examine is if there are any NAs or not applicables in the dataset. And the way to identify this is we can use the any function, and then within the any function we can use the is.na function, then we can pass in our data frame. And we see that the Boolean object false is returned in the console. So what the false tells us is that within the data frame there are no NAs. However, if we take a quick look at the dataset using the view function, you can see that we have some missing data elements. Here's one in row 13. We have another one here in row 31. So in this case, we don't have any NAs. However, we do have blank cells. In our syntax, a blank cell is indicated by two single quotations. So we notice here that the blank cells are not identified as an NA. So a good practice is to replace the blank cells with NAs. And we can do this using an indexing function, which is denoted by brackets. So in order to make this replacement, we can identify our data frame, and we can index by using brackets. So here I just typed the open bracket, and RStudio knew to also add a closing bracket. So within the brackets, I'm going to specify the data frame one more time, and I'm going to say is equivalent to an empty cell, which is denoted by single quotes. So similar to the brackets, all I did was type a single quotation mark, and RStudio knew to add a second single quotation mark. Now in order to make this replacement, we're going to use the get symbol, and we're going to say here that we want to replace the blank cell with an NA. So we can run this code, and now let's check again and see if there are any NAs in the data frame. We'll use the same any function. Within the any function, we'll use an is.na function, and then we'll specify our data frame. And you see here now that we have a Boolean value of true, indicating that we do have NAs in the data frame. So now if we take a look at the data frame again one more time using the view function, you'll see that where there was a blank cell, we now have an NA in row 13. Similarly, again in row 31. Now in large-scale data sets, one thing that's common is that any blank cells or NAs are indicated by the value of 99. So we can see if there are any values of 99 by using the which function. So just as a didactic example, let's take a look at Q16, Q17, and Q18 using the which function in order to identify which specific elements within those variables contain the value 99. So here we'll use the which function. We'll specify the data frame, which is SE1. We'll use the $ notation, and then we'll check our first variable, which is Q16, and we'll specify is exactly equal to 99. So we see here for the variable Q16 that the element in the 40th position, the 53rd position, the 99th position, and the 130th position each have a 99. Let's do this again for Q17 and Q18. So we see for variable Q17 that the value 99 is in position 40 and in position 130. And then for variable Q18, there's a 99 in position 40, 73, and 130. So let's now replace these 99s with NAs using the same indexing strategy that we used earlier. So rather than specifying the individual variables, we can replace all of the 99 values in the data frame in one command. So we'll identify our data frame, which is SE1. Again, we'll use brackets to index. And we'll say anywhere within data frame SE1, that is exactly equal to 99. We're going to replace it with an NA. And now if we go back and run these which functions, we'll see integer 0, which indicates that there are no elements within those variables identified as a 99. So now let's find out how many NAs total we have in our data frame. We can use the sum function, and within that sum function, we can use the is.na function one more time, and then we'll specify the data frame, which is SE1. And we'll see that we have an output of 14. So we have a total of 14 NAs in our data frame. If we want to see how many NAs we have in each of the variables, we can sum the total NAs of the columns using the call sums function. So call sums, and again, we'll use our is.na function, and then pass within the is.na function our data frame SE1. So we see for variable Q30, there's 1 NA. For variable Q9, there are 2 NAs. For variable Q16, there are 6 NAs, etc., etc. So with our data frame, we can either choose to keep the data with the NAs or remove the data with all of the NAs. And that decision really comes down to context or the type of statistics we may be running on the data, which is beyond the scope of this particular video. So for didactic purposes, let's omit all of the data with the NAs so that way we have a complete data set. So in order to do that, we're going to use the na.omit function, and we're going to assign that to a new object. So let's call this new object se_complete. We'll assign to it the na_omit function, and within the na_omit function, we're going to pass in our original data frame, which is SE1. And we can see in our global environment, we now have 150 observations across 6 variables. So a total of 9 rows were deleted. So now we've removed all of the NAs and we have a complete set of data. Another important strategy when we're cleaning data is to look at meaningless classifiers or miskeyed elements. So for didactic purposes, I've strategically put these in variable Q18. In general, we would have to look at all of the variables, but for here, we'll just look at variable Q18. So to look at all of the different types of elements that are in variable Q18, we're going to use the unique function. And then we'll call on variable Q18 within the new SE_complete data frame. So we see in the console, we have several different elements. We have strongly agree, agree, disagree, SA, disagree, that's lowercase, and then strongly disagree. So we know from this data set, we should only have 4 types of responses: strongly disagree, disagree, agree, and strongly agree. So there are 2 things that we need to change here. First, we have an SA, which should have been keyed as strongly agree. So we need to change that SA to a strongly agree. Second, we have a disagree, which is lowercase, and that got miskeyed, and it should be disagree with a capital D. So in order to change these, again, we're going to use an indexing procedure. For now, let's just look at the code, and we're going to talk more about specific use cases of indexing later. So what we want to do here is index the specific variable. So in order to do that, let's identify the data frame, which is SE complete, $ notation, and Q18. And then we want to use our indexing procedure. And we want to say that within this variable, anything that's exactly equivalent to disagree with a lowercase d, we want to change to disagree with a capital D. So again, let's specify the data frame and the specific vector within the data frame that is exactly equivalent to disagree. We want to change to disagree with a capital D. So let's copy this code to make it a little bit easier. And now the same thing. We want to change the SA to strongly agree. So anything within this vector that is an SA, we want to change to strongly agree. And now again, if we use the unique function on that vector, we see that we have our 4 categories: strongly agree, agree, disagree, and strongly disagree. And now we have a complete data set with all consistent data elements.